Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P1458, indicates an FTP fuel tank pressure sensor circuit range performance problem, specifically related to the functionality of the FTP sensor found in the Honda CRV from 2017 to 2022. The FTP sensor is essential in monitoring changes in pressure in the fuel tank to prevent fuel evaporation and control emissions. It helps to ensure the evaporative emission control system is functioning optimally. Located near the fuel tank, this sensor transmits pressure data to the Powertrain Control Module, PCM, which processes the information to manage fuel efficiency and emissions strategies. Correct functioning is crucial for vehicle performance, and issues can affect the overall driving experience and regulatory compliance. As you prepare to troubleshoot the P1458 code, it is vital to gather pertinent information, ensuring the vehicle is in the right state for diagnosing this specific error. The FTP sensor plays a crucial role in monitoring the fuel tank's internal pressure, aiding the vehicle in controlling fuel vapor emissions and ensuring it complies with environmental mandates. This sensor is located adjacent to the fuel tank and connects directly to the Powertrain Control Module, PCM. Its primary function is to send real-time pressure data, allowing the PCM to adapt fuel delivery and maintain engine performance. Proper performance of the FTP sensor is vital as it helps in diagnosing issues in the evaporative emission system, EVAP, which can lead to increased hydrocarbon emissions, affecting both fuel efficiency and regulatory compliance. When the DTC P1458 is triggered, it signals a potential discrepancy or range issue with the readings from the FTP sensor, warranting immediate investigation to preserve vehicle functionality. Several potential causes can lead to the activation of DTC P1458. A malfunctioning FTP sensor may not properly monitor or adjust the pressure readings, causing the PCM to detect a performance issue. Additionally, poor electrical connections, often resulting from corrosion or wear, can interrupt the sensor's communication with the PCM. Blockages in the EVAP vent hose or the FTP sensor's ventilation ports can also cause incorrect pressure readings, further complicating the sensor's performance. Conducting a thorough visual inspection and troubleshooting of these components is critical for effectively recovering from the P1458 code. Understanding these causes allows technicians to narrow down the specific issues impacting the vehicle's emissions controls. The symptoms associated with DTC P1458 often manifest as drivability concerns and can be easily recognized by the driver. A prominent symptom includes the illumination of the check engine light, indicating that the vehicle's onboard diagnostic system has detected a fault. This fault can lead to reduced fuel efficiency as the engine management system struggles to adapt fuel delivery, optimizing engine performance without accurate pressure readings. Another symptom is the potential increase in harmful emissions, which could put the vehicle out of compliance with environmental regulations. It is essential for homeowners and drivers to be alert to these symptoms, as they often indicate that the FTP sensor and associated components require immediate attention. The first troubleshooting step involves checking the fuel level to establish baseline parameters for further diagnosis. Begin by turning the ignition to the on position without starting the engine. Utilize the Honda Diagnostics System, HDS, to record the onboard snapshot parameters, ensuring to note the maximum and minimum values of the FTP sensor alongside the current fuel level. If the current fuel level is determined to be less than what is recorded in the onboard snapshot, it is mandatory to drain the fuel until it meets this requirement. This step is crucial in setting the correct conditions for analyzing the FTP sensor's performance, and ensuring accurate diagnostic results in subsequent steps. In this step, you must determine the possible failure area, primarily focusing on the FTP sensor. Using the Auto Diagnostics System, HDS, navigate to the EVAP test in the inspection menu and select the EVAP CVS off option to activate the single solenoid. Record a snapshot over 3 minutes without starting the engine, which allows you to capture a detailed performance profile of the FTP sensor. Following this, analyze the snapshot to confirm whether the maximum and minimum values of the FTP sensor are within the acceptable range of plus or minus 0.67 kPa, equivalent to 0.2 inches per second, or 5 millimeters per H. If they fall within this range, proceed to the next troubleshooting step. Otherwise, move to step 5 to check for issues in different areas. The third step focuses on assessing the FTP sensor's performance under monitored conditions. It requires checking the FTP sensor's performance indicator in the recorded snapshot using the HDS. Specifically, determine if the pressure reading shows variability of 0.067 kilopascal, or 0.02 inch Hague, or 0.5 millimeter H, or more, within a span of 3 seconds. An affirmative response indicates normal functionality, allowing you to move on to the next stage of troubleshooting. Conversely, if the FTP sensor shows no variability, this suggests an intermittent failure, thus indicating that the system may function correctly under certain conditions. At this point, it's essential to examine electrical connections and look for loose terminals at the FTP sensor, the EVAP canister vent shut valve, or even the PCM, alongside examining for any blockages in the EVAP vent hose. In the fourth step, the focus is on a more direct check of the FTP sensor itself to confirm its operational status. Start by turning the vehicle to the off position before removing the FTP sensor from its mount. After removal, reconnect the FTP sensor 3-position 3P connector, ensuring it is secured properly. Upon doing so, turn the ignition to the on position to power the system without starting the engine. Utilize the HDS to check and monitor the FTP sensor's performance. Once again, you will be looking for variations in pressure measurements. An indication that it varies by 0.067 kPa or more within a 3-second time frame implies the sensor is functioning correctly. If this condition is met, replacing the FTP sensor is recommended for ongoing reliability and optimal vehicle emissions performance. The fifth troubleshooting step involves identifying issues with the EVAP canister vent line or related components. Begin by inserting an emergency fuel funnel, which is usually stowed under the cargo lining, into the fuel filler neck and wait for approximately 1 minute. After this waiting period, utilize the HDS to analyze the FTP sensor's pressure values. It is crucial to check whether these values fall within the defined threshold conditions, specifically whether the FTP sensor reads above 0.67 kilopascal or below negative 0.67 kilopascal. If the current conditions align with this threshold, then proceed to the next troubleshooting step. Otherwise, it is necessary to remove the emergency fuel funnel and continue to step 8. In the sixth troubleshooting step, you're going to check the FTP sensor vent hose for potential blockages. Just like previous steps, your first action will be to turn the vehicle to the off position. Remove the FTP sensor and ensure the 3P connector is reconnected securely. After ensuring connections are correct, turn the vehicle to the on position and again check the parameters using the HDS. Monitor the sensor for the same thresholds previously established. It should read values above 0.67 kilopascals or below minus 0.67 kilopascals. If these conditions are met, the next step is to address any existing blockages in the FTP sensor vent hose and replace it if necessary to restore proper functionality to the system. The 7th step centers around physically checking the FTP sensor ports for obstructions or damage. Again, begin by turning the vehicle to the off lock position before disconnecting the 3P connector from the FTP sensor. A thorough visual inspection of the sensor's ports, which connect to the EVAP canister and the vent side, is critical to ensure there are no blockages or damage present. If blockages are found, they must be cleared to restore proper airflow and sensor functionality. If the sensor itself is found to be damaged, it should be replaced promptly to ensure reliable performance. If there is no visible damage or blockage, it is time to conclude the testing by replacing the FTP sensor to resolve the P1458 issue. In the last troubleshooting step, the focus shifts to the evaluation of the EVAP canister vent shut valve to ensure its operational integrity. Start by turning the vehicle to the off-lock mode and disconnect the vent hose from the EVAP canister. Next, connect a vacuum pump or gauge to the canister for testing purposes. After connection, turn the vehicle to the on position without starting it, and select the EVAP test in the HDS menu, choosing EVAP CVS off for the single solenoid. This allows for application of vacuum to the valve while monitoring the FTP sensor readings through the HDS. It is critical that the maximum vacuum applied does not exceed 5.3 kilopascals to prevent sensor damage. The valve should ideally hold above 1.3 kilopascals. If it does not meet this criterion, then the vent shut valve is functioning correctly. A replacement of the valve is necessary if it does hold, while blockages in the vent hose must also be checked and addressed. After completing all necessary repairs indicated by the diagnostic process, it is crucial to conduct a final verification to ensure the issue has been resolved. Start by clearing the diagnostic trouble codes, DTCs, from the vehicle's onboard system to reset the engine management parameters. Following that, perform a test drive under various conditions to determine whether the FTP sensor now functions correctly, without any reoccurrence of the P1458 code. Lastly, it is essential to recheck for any DTCs after the test drive to confirm that the issue has been fully addressed and no further anomalies are present. Ensuring successful completion of all monitoring and verification steps is necessary to validate the repair and restore optimal vehicle performance. Preventive maintenance is crucial in avoiding future occurrences of DTC P1458 and ensuring the longevity of your vehicle's emission control systems. Regular inspection of the fuel system is key. Monitoring for any deterioration or leaks in hoses or connections can significantly enhance system efficiency. Additionally, routinely checking the integrity of the FTP sensor itself for any signs of wear or electrical issues can prevent unexpected faults. Keeping the entire evaporative emission control (EVAP) system clean and free of contaminants will help maintain proper functionality, ensuring that it continues to meet emission standards and operate efficiently. Establishing a systematic maintenance routine that incorporates these checkups can mitigate risks of encountering the P1458 issue down the line. In conclusion, understanding the role of the FTP sensor is vital for maintaining the vehicle's emission control systems and overall performance. By strictly following the comprehensive troubleshooting steps for DTC P1458, including checking fuel levels, inspecting connections, and assessing the vent shut valve, technicians can identify and resolve issues effectively. Remember, regular maintenance plays a crucial role in preventing similar issues from arising in the future, encouraging drivers to conduct periodic checks on their fuel systems and EVAP setups. A proactive approach to vehicle care not only ensures compliance with emissions regulations, but also optimizes fuel efficiency, enhancing the driving experience by minimizing cost and environmental impact. Please like and subscribe to the channel. See you next time!